This is TMUA 2021, Paper 1, Question 1. We're given that two circles with the same radius, with centres at -2, 1 and 3, -2, intersect at two distinct points. And we're asked to work out the equation of the line which goes through both of these intersection points. Okay, so let's maybe try and work out where these two intersection points are. So what is the equation of one of these two circles? Well, the general form of the equation of a circle is x minus the x coordinate all squared plus y minus the y coordinate all squared equals the radius squared. So in the case of this first circle, it's x minus -2 squared, which is the x coordinate, plus y minus 1 squared, which is the y coordinate, and that's all equal to r squared. And r is just the radius of the circle which I've called. We do the same thing for the second circle, and note that we have the same r here as for equation 1, because they have the same radius. So what does it mean for these two circles to intersect? They intersect at a point, say, xy, if xy satisfies equation 1 and also equation 2. Therefore, an intersection solves both of these equations. So let's maybe try and progress and try to solve these two equations simultaneously. Expanding equation 1 gives us this expression by expanding these two brackets, and we'll call this equation 3. We can do the same thing for equation 2, and we get equation 4. Okay, so the options we're given in the question are all lines. So we want to eliminate quadratic powers of x and also this r term, because that's a variable that we've come up with. So how might we do that? Well, we notice that if we take equation 4 minus equation 3, the r squareds cancel, as well as the x squareds and the y squareds. So let's try and do that. That gives us exactly minus 10x plus 5 plus 6y plus 3, and it's all equal to 0. Simplifying this down gives us 6y minus 10x plus 8 equals 0, and dividing through by 2 again gives us 3y minus 5x plus 4 is equal to 0. I'll call this equation dagger. So what does a dagger mean? Dagger means that if xy satisfy equation 1 and equation 2, then it must also satisfy dagger. So any intersection point of these two circles must lie on this line. But what do we know about a line? We know that once we're given two distinct points of a line, then we've immediately uniquely determined the equation of the line. There's only one straight line going through 2 points. Therefore, this equation, 3y minus 5x plus 4, is our line. So the answer is F.